Hey guys, it's Mr. Bernay. I'm going to go through some of these questions on the probability test review. So the first one is a list of ice cream flavors, candy toppings, and liquid toppings for the ice cream. It says ice cream comes with a choice of one flavor, one candy topping, and one liquid topping. Mr. Bernay makes a list of his options as shown below. So again, here's the menu: ice cream flavors, candy toppings, liquid toppings, and here's the list. So there are two options for each part of the menu. So 2 times 2 times 2 should be 8 outcomes. We see that there are only 1, 2, 3, 4, 5, 6, 7 outcomes listed. So which option did I forget to include on my list? Option A has chocolate and marshmallow. Well, it says that we need one flavor, one candy topping, and one liquid topping. Chocolate and marshmallow is an ice cream flavor and a liquid topping. So that list doesn't work because it doesn't have candy. So it can't be that one. This one, mint chip, Butterfinger, hot fudge. It has an ice cream, a candy, and a liquid topping. But if I look up here, I have mint chip, Butterfinger, and hot fudge listed. So that one can't be right. C, mint chip, M&Ms, and hot fudge. That could be one because it has ice cream, a candy, and a liquid topping on it. And I didn't list it here. Mint chip, M&Ms, marshmallow is listed, but not mint chip, M&Ms, and hot fudge. So the answer would be C there. The reason why it's not chocolate, Butterfinger, and M&Ms is because Butterfingers and M&Ms are two types of candy. So that one doesn't include the ice cream, the candy, and the liquid topping. So the answer there is C for number 1. Number 2 says Mike will spin the two spinners below. What is the probability that he will land on 2 even numbers? So this one is a compound probability problem. Since there are 2 events happening, you're spinning this spinner and you're spinning this spinner, so that's 2 things that are happening. We're looking for even numbers, so 2 even numbers. So when you spin this spinner, the probability of landing on an even is 1 out of 3 because 2 is the only even number. So 1 out of 3 is the probability there for that spinner. Over here, probability of landing on an even number, there are 1, 2, 3 even numbers, 2, 4, 6, and there are 6 pieces of that pie altogether, 1, 2, 3, 4, 5, 6. So the probability is 3 out of 6 there. Since this is a compound probability problem, that means we have to multiply the probability of the first event times the probability of the second event. So 1/3 times 3/6. 1 times 3 is 3. 3 times 6 is 18. So my answer there is 3/18, which also simplifies to 1 over 6. Because 3 goes into 3 one time, 3 goes into 18 6 times. So the answer for number 2 is 3/18, 3 out of 18. Number 3. What are the probabilities on the number line show your work on the paper? So in this one, this is the one about the bag of marbles. 30 marbles in the bag. And it lists all the numbers of the different colors. And you have to plot them on a number line here. It goes from impossible, which is 0%, to 100%. And then in the middle is 50%. So A, drawing a red marble or an orange marble, well, there are, let's see, 6 red marbles, 4 marbles are orange. So 6 plus 4 equals 10. There are 30 marbles in the bag, So 10 out of the 30 marbles are red or orange. 10 out of 30, 10 divided by 30 is 0.33, which is 33%. So for A, the probability is 33%. For B, drawing a red marble, a green marble, or a yellow marble, again, you just add those up. So red, 6 reds, how many greens? Plus 8, and yellow, 7 yellows. So 6 and 8 is 14, plus 7 is 21. 21 out of 30 are either red, green, or yellow. So on the calculator, 21 divided by 30 right here to get my decimal, which is 0.7, which equals 70%. So that's B. 70% for B. C, drawing a yellow marble or red marble. So 7 yellows plus how many reds? 6 reds equals 13 over 30, which is 13 divided by 30 equals 0.43, so that is 43% for option C. D, drawing an orange, blue, or red. Again, we're adding them up. 4 orange, 5 blue, and 6 red. So that is 11 out of 30. 11 out of 30. Calculator. 11 divided by 30. 37%. 37%. And the last one, drawing a green marble, blue, or red. Lots of numbers to add up here. So green is 8, blue is 5, and red is 6. So that's 19 over 30. 19 divided by 30 is 63%. Alright, so we're not done because now we found the probabilities of all these as percents. Now we have to plot them on the number line in order. So we're looking for the smallest one, which is 33%. So that goes between 0 and 50%, right about here, which would be A. The next highest is D, 37%. So 33, 37, 43 is C, 43%. So I've got A, D, and C. Now the next is 63, which would be E, which is past 50. So that's E, 63%. And then B is 70%. So that's the probability. So I calculated each probability by adding up all the options that they give me, dividing by 30 because there are 30 marbles on a bag. That's how I got my percents. And then once I have my percents for each one, I put them in order from least to most likely. Yeah, and this was 37% here. So that's number 3. That one takes a little while. Alright, number 4. Students conducted the following experiment 20 times. They drew one card from a box with some red cards and some black cards. They put the cards back in the box and then drew another card. And the results are shown in the table below. What is the experimental probability of drawing one red card and one black card? So to draw one red card and one black card, and we're looking for the experimental probability. Experimental probability means that it's the result of an experiment. So it's the opposite of theoretical. So it's not in theory, it's the actual results of an experiment. So here is our experiment right here, and there's the results. And we're looking for one red card, one black card, and the only one over here that has one red card and one black card is this mixed category. We don't want two black cards. We don't want two red cards. We want one red and one black. So we're looking at the mixed. So 12 times out of those 20 experiments, they pulled one red and one black. So 12 out of 20 is the answer. I don't see that down here, and that's because I need to simplify. So I want to think what number goes into 12 and 20, and that is 4. So I divide 12 by 4 to get 3. 20 divided by 4 is 5. So 3/5. B should be the answer. Alright, number 5. Mark has the cards shown below. All cards are the same shape and size. He puts the cards into a bag, pulls one card out of the bag without looking. Mark will perform this experiment a total of 72 times, replacing the card after each pull. What is the total number of times he should expect to pull out a card with a 9 on it? So the first thing I would do here is look at the cards and think about, what are you trying to pull? You're trying to pull a 9, a card with a 9 on it. So in this group of cards I see 1, 2, 2 9s out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cards total. So the probability of drawing a 9, a card with a 9 on it, is 2 out of 12. But we're not pulling, he's not pulling 12 cards. He's pulling a card, he's performing an experiment, a total of 72 times. So 2 out of the 12 cards are 9s, and he's pulling a card 72 times. So what I would do is 2 divided by 12 to get my percent probability, which is, we'll round up to 17%. So 17% of the cards are 9s. Of cards are 9s. So if I draw 72 cards, or 72 times, I should expect to get a 9 17% of the time. So I want to know, what is 17% of 72? So I'm going to take 72, multiply it by the decimal equivalent, which is 0.17. So that's what I got for my decimal when I did 2 divided by 12. So I'm going to take that, because I rounded up, and multiply it by 72, and I get 12, which is right here. So again, if 2 out of the 12 cards are 9s, that means 17% of those cards are 9. So if I want to know how many 9s I should expect to get when I pull 72 cards, I do 72 times 17%, or the decimal equivalent, and get 12. 17% of 72 is 12. 17% of the cards are 9. So that's why these match.